name it. If it has a network connection card, it probably has SNMP capabilities. It could, obviously, the routers and the switches have them. It's very popular, and it's usually the reference for SNMP. Use that for network devices, network switches, and access points, routers, excuse me. But it could also go beyond. My Mika Verde Verilight home automation system has SNMP. My HVAC unit has SNMP. What do you know? You could probe it to get the room temperature if you want. So there's a lot of things, PDUs, APCs, whatever. And the capabilities will vary between some operating systems to something, a hardware appliance. If these mics were IP or you have an IP phone at your desk, the IP phone has SNMP capabilities, probably very limited to its own hardware. The main purpose of SNMP is to collect statistical data about its local environment. So it's always the agent runs on a device to collect data about its device. That's the primary use. There are some exception cases where you can actually make it do more, but primarily the agent runs on a system that it gathers device information for this device. So the ports and the firewalls, if you're doing the SNMP throughout the inside of a LAN that doesn't have any firewall rules or anything, well, just so you know, it's part of a transport controlled protocol, IP protocol, also known as TCPIP, and it uses UDP mainly for over port 161 and over 162. 161 is utilized to actually go and get data. So from a manager reaching out to an agent, asking for data, that's 161, and 162 is what we call the trap. Here's a very simplistic arrangement of a manager and an agent. The get set request here and the information being returned, that's port 161, and a trap is over 162. Briefly, a trap is something that's sent from the agent out to a manager to alert the manager that something happened. It could be a network interface status change. It could be a server reboot. It could be something, but a trap is sent from the agent to the manager, as opposed to the usual traffic over 161 being pulled by the manager. This is usually statistical data that's going to be, the manager is reaching out to the agent to get the data and collect it over time. If you have, this is the extended topology or the way the agent will work. So the agent 6 there is, most of the time, that's the type of communications you're going to have. If you have a setup that's spread across a LAN and a WAN, and let's say your manager is on the WAN side hosted somewhere and he needs to reach out to your agents, if these agents are publicly available, you manage it through firewalls, the UDP ports, 161 and 162. If it's behind NAT, you can NAT some ports. If you have one or two devices, that will work. If you want to get something smarter, the SNMP agent has some capabilities to act as a proxy. So you can do NATs of port 161 to one agent and have that agent go out inside your LAN and get data from the other devices. Same thing for the traps. It can actually act as a relay back to your manager. So that's something to know. It's some cases this is going to apply. If that's the case, we can definitely talk about it later. But I think most people here are going to do manager to agent, either WAN to WAN or inside of a LAN. For those of you who don't know, UDP does not have any mechanisms to acknowledge that the communication has been received by the other peer. So that's one of the things. It's a plus because it's very light on the resources, on the machine's resources. But it's also a drawback because if the information is not sent properly, let's say a trap, we can't know because it's not going to be re-requested. When the manager reaches out to an agent to get some data, if for any reason inside the UDP connection, the packet gets lost, it gets corrupted, anything, the manager will usually go back and ask it again. Pretty straightforward. But for the traps, it's different. Some of the different versions of SNMP will address that. Keep in mind that most of the times the UDP packets and any SNMP data is extremely small. We're talking extremely small packets. So rather than just using TCP to acknowledge that it's been received, there's more overhead if we were to actually use TCP over UDP. So just keep it in mind. What else is here? That's the most likely scenario that you will encounter. You have a manager and you have the agents. That's all on the same LAN or on the same WAN. Moving on to the components. Typical architecture is a manager, agent, devices, or application. You see here on the graph, if I start from the top, you've got a manager. That's a software we're going to talk about. You've probably heard there's Cacti, Xenos, Nagios, there's OpenNMS, there's Uptime, there's lots of free and commercial software. That would be your manager. That's what goes out, gets the data, statistical data most likely, and graph reports, create thresholds, all sorts of things. We'll also manage the traps. The device, well, obviously it's any piece of device that we covered, so anything that has network capabilities. And the agent, these days, every hardware, every device has its own agent embedded inside. The agent part of the SNMP protocol on the Linux-based system uses Unix socket to communicate. So you've got the process that uses inside the operating system Unix sockets to talk to the agent. The devices could be network devices, could be virtual, it could be physical servers, it could be, like I said, any operating system. In the versions of SNMP, you've got three standards. You've got the version 1, 2, and 3. The version 2 is referred as 2C, as it's the C revision of the second version of it. But it hasn't been developed or improved since, I think I went too far. Hasn't been improved in sometimes. Yes. I would say the most popular one is the version 2C. Version 1 dates back in 88 or something. It was the first version of it. Its main limitation, 32-bit counters for integers. What it means is the counter, the number, cannot go bigger than a gigabit per second. So if you have, for instance, that's just a number, but a network card that has gigabit per second capabilities, that 32-bit counter is going to actually reset and go back to 0 at some point. So that's the first reason to use version 2. Okay, version 2 has some performance improvements, and it also has what we call bulk request. We're going to talk in 2 slides about the OIDs. That's actually the piece of data that we want to go and get. In version 1, it's a one-on-one. You want to know the uptime, you query, and it returns the uptime. You want to know CPU load average, you query CPU load average, it returns the value. Bulk request will say, I want to know CPU uptime, CPU utilization, free memory utilization, I want to know uptime, and then it will return it. So that's the bulk request. All of that is done, version 1 and 2 is done over clear text. In some situation, clear text is not acceptable on networks. That's why they came up with version 3. Version 3 will do 2 things, mainly 2 things. It could encrypt and it could authenticate communication. If you need to have version 3, there are 4 points I'm going to go over. Basically, version 1 and 2, you have a community string. That's the community string you need to provide to the agent to be able to actually receive information. That community string, by default, is called public and is always sent in clear text. So packet sniffing, you grab it, then what do you know? You can go and get information about a system. But SNMP is not just for reading data. it could also write data to a MIB, an SNMP agent. We're going to see that in a second. So on version 3, they introduced what they called SNMP Engine ID. SNMP Engine ID is two strings that the manager and the agent needs to know before they can communicate with each other. Similar to a tunnel identifier in an IKE VPN tunnel. It's the first key that's used by the two peers to communicate to each other and then increase their level of encryption. In version 3, they provide, I don't know if you can read it, it's no auth, no priv, auth and priv, it's one or the other. So it's no auth, no priv, auth, no priv, or auth and priv. It's authentication and privacy, or one and another. It's basically encryption and authentication. So if you need to have encryption in on your network, that's one. If you need to have authentication, you have the other one. You could use both if you want. Version 3 even goes beyond all of that. You can pretty much, in its most secure deployment, it's basically doing an RSA private public key exchange and establishes an SSH tunnel between the manager and the agent. So SNMP version 3, if you need security in any sort, it's definitely the version. The version 2C is the most popular one. It's extremely simple to control and set up. And if you can get by the fact that your data is being transmitted non-encrypted over the network, that's fine. The MIB and the OIDs are two main components. So a MIB stands for Managed Information Base. It's a gigantic tree with all sorts of data. And OIDs are object identifiers, are the address inside the tree to reach the data. So the tree that we see here, thanks to Joshua, I've got a laser pointer, starts at the root and then it goes down. So for instance, system uptime is .1.3.6.1.2.1.3. So if you go here, the dot is there. So that's 1, that's 3. I can't read here, I think it's 6. 1, 3, 6, that's 1. Here's 2. So you could go down here. And the tree extends way beyond what you can imagine, and you can actually build it the way you want. There's RFCs and standard informations to place standard data inside the tree, but that tree could be extended, and Manuel's going to cover that. But basically, you can get any information relevant to you inside your system and place that data inside the tree. And through the Net-SNMP agent, you tell your manager, go get, this is the OID, blah, 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 all the long number, and you're going to be able, through SNMP, to go and get statistical data that, out of the box, you couldn't. Those informations could be populated inside the tree by a simple script. Any script, any language, you could actually put it, or almost any script, you can put it inside the tree. So you can go and get it through your unified NMS or EMS system. So that's a good thing. So the MIB is the tree, and the OID is the address inside of the tree. There is also MIB files. They are basically dictionary to tell you what address that .1.3.6.1.2. something means, because that's a short one. System uptime is a short one. You can have extremely long ones, and manufacturers will usually, if they're nice with people, they will provide a MIB file telling you that here is our extension for our piece of hardware, and you can get, for instance, a power outlet amperage at this address for the plug 1. So a MIB file description is what you want to read, but the system doesn't care. The manager and the agent only uses the OIDs, the numerical version of it. So for you to actually identify what OIDs you want on a specific device, you're going to use two tools. I'm showing you that in the last slide. It's a MIB browser and the MIB file description. So combine them together, you're going to be able to actually see and it's going to give you some meaning about those numbers. The commands that you could actually that are part of the SNMP. Before that, I've got a last slide. So that's the translation between the MIB actually the OID number and the text version. At the top here, you've got the uptime. The uptime OID is this 1361213. If you translate that and you look, that is actually part of the RFC. So if you look at the RFC 1213, I believe, it will tell you that this OID is called system uptime, but it's actually called disman event MIB. So that's the MIB file, and inside that you've got this description. And if you browse down the text file, usually there's a brief description. It's probably going just to tell you it's uptime. But that's how you actually translate text or actually MIB files to know that this Aruba Wi-Fi access point, the amount of client connected, if you want to get that, it's definitely part of their SNMP agent. You just need to find the OID, the number here that you want to get, and every time you query it, the access point is going to return how many clients it's connected. Okay? So that's the basic principle. You find the OID that you want to monitor, and you go and get it. When you transmit traps, when a device sends a trap to a manager, if you don't have the MIB file description, it will send you a trap. A trap is basically three things: the system uptime, the OID of the trap, and I think I've got it in the second slide, the type of trap. And so if you don't have the file description, what you're going to get is a big number. That doesn't mean anything. You're going to need to go and look for what it means to translate it. Maybe it's going to tell you that there's the airtime on the access point has reached critical point. So you need to address that. If that happens, every now and then, take action on it. It could also be that a RAID system failed. So you've got one drive that failed, but it's going to send you the OID, the number. So having the MIB description on your manager will automatically translate that to actually get you the description of that OID. So on the commands, you have a couple of things. You can do get next, get bulk, set traps, inform, response, and so on and so on. Most of the time, a get is getting a single OID. You have one number that you want to get, like the uptime example. You do an SNMP get, you pass it on the community string. It's kind of an authentication method, and you pass it on the OID that you want to get. What you're going to get as an answer is the value of that. So you're querying the tree, and it returns the value. The get next basically exists because the tree is for integers, but also has table. So for instance, if you want to list all the different network interfaces on a laptop, 1 or 2 or 3, if it's the same section inside the MIB for a network switch. So 2 or 3 may not be exact. So the tree, the way the MIB is made, it kind of creates a default subset of information for one interface. And it will generate a table with X amount of interface and actually replicate that. So I don't have an example on the slides, but let's say that the .1, so the end of it, .1.0, is the amount of data transmitted on an interface. And the .2.0 is the amount of data received, and so on and so on. So you're going to have, so if .1 is transmit, .1.0 is the value, you're going to have 1.1.0 to be the first interface. And you're going to have 2.1.0 and 3 and so on and so on. So tables are managed pretty well in the MIB for one interface, 200 interfaces. It doesn't matter, it's just a tree, and you've got the address to actually go there. So get next will actually tell the MIB agent to go to the second information. just to actually make sure through that process that it can actually go and scan the entire MIB for any interface that you may have. Set as the command, as I said, SNMP, most of the time we talk about getting information out through traps or through get. But an SNMP agent can also set information. It has read and write capabilities to your system. This is something that most people actually don't explore, but it's a good way to standardize, or you could leverage the capabilities of an SNMP agent, which is widely spread, to actually write information to your system. So the set value obviously is to write information. When you manage the community string to authenticate to the agent, there are two different subsets of authentication. The community string for read and for write could be different. Obviously, you want that. And by default, it's private and public. Yes, for read and write. Traps, as I said, information sent from an agent to a manager. This is for alerting something has changed. Somebody unplugged your server connection on your HP switch. So you know that port 48, if you've documented stuff inside the switch and you name the port, connection to very important server will send you a trap, and you're going to know that this interface went down and it's very important server that went down. So you know it, let's say the server just blew, it's not going to, most likely not going to be able to send you a trap saying, hey, I'm blowing up. But the network switch that it's connected to could tell you that the port went down. It's another way to find that. And all of that information is managed inside your network monitoring solution or element monitoring solution, NNS, or actually through the manager, regardless of the application. Informs and response are for traps, information being passed on one way. Also, in the tree, there are standards, RFCs. So there's a certain part of the tree, you can change it if you want. Not recommended, it will conflict with some other stuff. If you want to properly do custom extension to the tree, there is a nice organization here that will, if you fill out the form, it's free, will assign you a number, a PEN, private enterprise number, where inside of the tree, there's a branch that's going to be just for you, only for you. So anything that you attach or the way you want to manage it, it ensures that it will never conflict with any other vendors, okay? And every vendor has one. That's, I went too fast. Yeah. Oh, you see it here. So, it was actually the one before I wanted to show you.
Can't see that display very well.
You can't?
No one can read that.
Well, you don't actually need to read this. It's just the way it's organized. Don't read it. I just put it there so there's content there. That's actually the beginning of that gigantic list of every entity who requested a PEN number. And the first one at the top is reserved, obviously. We don't know why. But the second one is NX Networks. IBM is the second one. And it goes on. So that's 2, 3. And the other ones here, we've got the Penn State. Oh, sorry. That was the laser pointer. Really? Yeah. So you've got the Penn State number here. That's 14,352. Here's Symbiotic Systems Design. That's Manuel. Here I am, 44,510. So that ensures that anything you want to put inside the tree, when you extend it, you want to add stuff, will never conflict with anybody else. So every vendor should be on that list. Some are, Most of them are, thankfully. It takes a day to receive your number. So if you want to get to that, instead of just taking one and putting your data there, and then realizing down the road, 2 years, 3 years down the road that, you know, a manufacturer, you're either part inside the RFC slide, the RFC section of the tree, or you're just conflicting with something else, just request it and put your stuff there. It's just plain nice with the other ones.
There's no reserve for private use number like there is with IP-based?
I think there is. Is there?
If you don't specify the OID you want the data return, it goes to a standard branch for the extend purposes. But then you can conflict because you get your laptop's battery data on that OID, and some other guy on the same OID will be getting RAID status. So it kind of hinders collaboration. The minute you start to make your own extensions, get a PEN number, chances are they're sequential. So you saw Penn State was at 14,000, means they've had it for a long time. I'm at 44, he's at 45.
44. I'm at
43, and I'm at 40. So it keeps growing. So it ensures that whatever you develop is unique and doesn't get stepped on.
So the stuff that I want you to check out, starting at the top, OID view. It has a Java or Flash-based browser, which is fine. But there are better ones for MIB browser. But the OID view website has a gigantic database of MIB description files. Every vendor has a different way of putting it out there. They don't usually revise those files often. HP has some 2007 files. Some of the stuff doesn't change, fine, but you always need to go at the manufacturer and find where it's at. And sometimes it's actually very hard to get a MIB description file. So if somebody has already done it, they probably posted it on OID inside the database. So go check there. That's one thing. Manage Engine. They do all sorts of management tools, but they've got free ones. And one of the nice ones is it's a free MIB browser that you can actually load the files to. A MIB browser is a tool that you're going to use to actually query your device, load the MIB file, the MIB description file, and you're going to get all of the tree. You're actually going to what we call walking a tree. So it's basically outputting everything inside the tree. And you're going to find through the description file what you want to actually get. That's one way to do it. And they have a free tool that works great. It will also manage the traps. So if you want to get started with managing traps and making sure it's relevant, the stuff that you have, the software when running, it's just a standard app, doesn't have a backend that keeps running when you quit it, but you can load the MIB files and you can have your device send traps to your laptop or to your desktop, to the application, and it will behave as a network manager will. The other one, so definitely a great tool. There was one that worked until 10.9. That was called iReason or iReasoning. Can't remember. That was a Java-based application that you could use for free as personal use. But it stopped working for 10.10. I haven't been able to make it work. If somebody has, great. That tool works. It's like. You did?
Yeah.
Well, great. I actually, I was tired of trying to make it work. So I just Googled another one and found the Manage Engine. The other ones here are Cacti that I mentioned. This tool primarily does statistics. It will gather information through anything, and one of them is SNMP, and it will build nice graphs. The other ones will do as well. So Nagios here, you've got Joshua right here. Raise your hand so that everybody knows. Tomorrow, 10:15, has a session. 10:15? The second session tomorrow morning. Has a great Nagios installation. He's going to do a lot of stuff on that if you want to see that in action. Xenos, I use that. Manuel uses that as well. That's another free tool. There's Open NMS. There are tons of them. Uptime software is a paid one. So, but I put it here because I've seen it deployed in some companies. The main difference between the free and a paid version is what it does out of the box, plus the assistant tech support. That being said, Xenos has also a paid with support version or a free version, so they also have. Nagios has that too. So that's the way they decided to go, and Uptime is a great software. So outside the box, it will do 90% of pretty much any device out there. So that's a good option to actually see. After that, what goes after? A small Q&A session while Manuel plugs in his laptop.